machine that was like that.
You ever heard Mr. Singer's joke, what is it called when he and I go bowling?
Hyperbola.
It's a parabolas. Okay. So if somebody goes bowling and they forget their meds, there'll be a hyperbola.
We can crop in the laughter.
Yes. I'll edit in the laugh effects. All right. Now,
Crumpling.
okay, so hyperbolas. A lot of this overlaps with ellipses, so I may not have to go as long today as I did yesterday.
Yay.
Awesome. 'Cause that took forever.
The standard form, not the general form, I want to say this correctly. The standard form of a hyperbola is x squared over a squared minus y squared over b squared equals 1. The other standard form of a hyperbola is if I switch these and I make it y squared over a squared.
Does that matter?
And it actually does in this case.
Because it's subtraction.
Right.
Equals 1, yes. Because it's subtraction, you'll get two different things. These are the two general forms, and I'll give you... Oh, another thing is, at this point, we're still talking about centered at the origin. Because there is nothing being subtracted inside the squared from the x and the y. Nothing being subtracted from the x or the y inside the squaring. So this is centered at the origin. So which one comes first is a big clue. Hyperbolas come in two general shapes at this point in your math career. They'll come in more next week, but for now, be glad. X squared minus y squared equals 1 will be of the form... What's the difference between the two types of hyperbolas?
They face different directions?
They face different directions. If x squared comes first, which way does it face?
The X.
Horizontal.
It's horizontal.
Like this.
Well, yes, it's actually nice and consistent with what we said about trig. X still means horizontal.
Oh, hyperbolas are the hard one.
So the wings are going to go left and right in this case.
You do the square.
If the y squared comes first, the wings are going to go up and down. Okay? If the x squared comes first, the hyperbola intersects the x and negative x axes. If the y squared comes first, the hyperbola intersects the y and negative y axis. All right, you guys can see, imagine your plane slicing through your cones, creating one of these two shapes.
So there are two y-axes?
Y and negative. Some people say y and negative y. It's really just one axis. Anyway, so these are the two types. Any questions on this before I go into more detail? On it. These are the start of what we're talking about.
Start something new.
Start something new. I'm going to go right to an example and show you how this compares to an ellipse. So if I have... Oh, actually, one more bit of information I'll give you. The foci.
They're on the outside.
They're on the outside now. They're further away.
But they're equally.
So c squared in this case is going to wind up equaling a squared plus b squared.
Oh.
For hyperbolas, the way you find the foci looks just like the Pythagorean theorem. I'll show you how to use that specifically in a moment.
Like they have to redo the homework.
Where your foci, if you did it minus, your foci would have been inside, in between the
They
wings.
sort of were.
Okay, yeah, the foci are always out here, inside the wings.
I used to remember.
Like the peak? Are they like the peak of your dome?
No, they're not on it. Your intercepts are like the peak of your dome. Your foci will actually be somewhere
Oh.
inside each wing, not in between them.
Okay, I saw your little dots on
No, sorry, those were the intercepts. But yes, equally far from the center.
I used to
Joan, is
remember
correct.
because hyperbola is like negative and then 1, so the foci is plus, and then the parabola is plus, and then that's negative. So they're like opposite to each other.
Yes, that's good. That's a good way to look at it.
Hyperbolas.
Don't get too used to comparing these to parabolas, though. Like I said 2 days ago, you can never superimpose a hyperbola on a parabola. The shapes are too different. Some crazy reasons for that. But yes.
Why? You know how like in ellipses, the two foci like you bounce off each other perfectly and
Right.
everything. But in hyperbola, do they do anything?
Yes, and I didn't plan. I was going to go over that next week, so I didn't review what they do. It's something really weird, like.
You don't know?
No, off the top of my head I remember, but it's something really strange, like if this were a reflective surface of some kind, then a ray bouncing here would always bounce through this focus, but there's a little more to it than that. So you can actually use this to get things. It's really weird. And honestly, I don't, especially on YouTube, I don't want to say anything more inaccurate, so I want to double check
Maybe
that
it's
one.
like, this is really stupid, but you know how when you have glasses,
Uh-huh.
and like they bring all the light into one point?
It's a little bit similar to that. Yeah, it has to do. You can make hyperbolic lenses. You can
Oh.
make hyperbolic lenses.
I didn't even say anything.
But I forget what the glass. But I honestly forget how glasses work. I haven't studied optics in a long time. Okay, let's do an example of this, and by next week I'll have an example of how the focus works. Okay, so if we look at, I'll keep it centered at the origin first.
Sorry, Jim, you're not gonna fit that.
Okay, so x squared over 9 minus y squared over 16 equals 1. How do you graph it? Now these steps are, hang on, don't speculate. For one thing, Becca didn't have this last year, so we have to make sure she gets through the drawing the box and everything that the rest of you remember so well.
Thank you.
I remember
Remember that?
so well now.
Okay, so a squared and b squared start out serving a similar role on the hyperbola that they did on the ellipse. Okay, so in this case, I know that a equals 3
There's a problem.
and b equals 4. Okay? So guys, stay with me here. Now, because the 9 is under the x, I'm going to go 3 units out on the x-axis in both directions from the center. Because the 16 is under the y, I'm going to go 4 units up and 4 units down on the y-axis. So the a squared and the b squared start out similarly. I'm going to change colors now. The way I use the 3 and the 4 is different. And Becca, this should be brand new for you. I am going to draw a rectangle. And the rectangle is going to be 8 units up and down and 6 units across.
You mean 4 units up and down?
Yeah, what's with the 8 and 6?
It's going to have a total length of 8. I'm sorry, total length of 8, total length of 6. So it is going to be 4 units up and 4 units down, or 8 units up and down is how I was thinking of it. It's going to pass through. The sides are going to be perpendicular to the x and y axes. It's going to pass through the y-axis at 4 and -4, and the x-axis at 3 and -3. Now, once you've drawn this rectangle, you then have to draw 2 lines. And these 2 lines have to go across the diagonal of the rectangle and keep going. So the line has to go through the diagonal of the rectangle, which will take it through the center of your hyperbola. To draw these 2 intersecting
You don't have
dotted
to draw
lines.
these.
Pardon?
You don't have to put these.
I think I'm going to insist.
It helps.
Oh, what?
Are these
Mr.
asymptotes?
Mr.
These are the
Guy-
asymptotes.
Mr. Singer said that you didn't have to. Like,
Yeah,
I
you
mean,
do.
he said
I'm going to insist.
if-
Okay, I know. Welcome to honors. Welcome to the next year. Welcome
Yeah,
to
but
pre-cal.
shouldn't you be able to do it accurately then without the box?
No. No, I can't. Anyway, so you draw the box.
And if I can't, that means
You
you
can't.
right?
You draw the you draw the asymptotes, and now here's how this helps you. Asymptotes, yes. Okay, thank you, Ramsey.
So
Now,
bad too.
x squared comes
Asymptotes.
first. Stop. X squared comes first. So which kind of hyperbola am I looking at? One that goes where the wings are vertical, or one where they're horizontal?
Vertical.
Vertical, correct. Now, this 3 and -3 are going to be my intercepts.
Wait a second, I thought you said that the exponent was horizontal. That's what you said over there.
And I started to do it. You know what? You're right. It's, guys, did you all just say vertical?
Yeah.
And I nodded along?
I did.
Yeah.
Thank you. All right, we'll check the proof later. Guys, the x in
It's there.
first is horizontal. X in first is horizontal. Okay, so that's this way. The x-axis points where your box hits are going to be your intercepts of your hyperbola. And then your hyperbola has to follow first the side of the box, and then the dotted line you drew as an asymptote.
See, it's going vertically.
Those look like the X.
That's seriously what I thought.
That's seriously what you meant?
Yeah, actually, yes.
Okay, well that's one way to picture it. As long as you draw it correctly.
Mr. Balbo.
That's not good.
Yes.
The B squared is under the Y. Like the bigger one's under the Y.
Yeah.
And that doesn't.
Okay, good point.
It's negative though.
Good point. The only